Okay, so now let's working on the intermediate geometry, intermediate algebra of the A ops. This is for the question for the chapter or challenge problem for chapter 1. And the first question is the tennis player computes her win ratio by dividing the number of the matches he won by the total number of the matches he played. At the start of the weekend, his start win ratio is exactly 50-50. Then during the weekend, he played the 4 games and winning the 3 and lose 1. Then at the end of the weekend, her win ratio is greater than this. So what the largest number of the matches he could have won before the weekend? Okay, so before the weekend, we know the win ratio is 50, right? 50-50. Now over the weekend, he won 3 of them, but totally played the 4 games. Then this one need to be greater than the 0.503, right? So we want to solve this equation, right? So the equation now let's expand is n plus 3 is greater than uh, the 1.006 n, right? Then plus the 12 is 2.012. Then this is equivalently to move the 0.006 n should be less than 0.988. Then this means the n should be less than 988 over 6 is 164, 3 over 2, right? So the maximum he can win before the weekend is n equal to 164. Okay, then question 32. Find all x such that, let's see the first side, okay? If we want to x greater than the -4, so you can see is the -1/4 is the point here. So you can see you want the denominator, the absolute value, to be as large as possible, right? For example, if it is a 4, right? So definitely -4, right? Definitely 1 over -4 will be greater than this. So now we know x should be less than 1 over 4 for the first side. Okay. Now for the second side is 1 over x should be less than 3, right? So we should be wish to x greater than 0, but we should wish it to be the less than 1/3, right? So now you can see, uh, I mean greater than 1/3. Sorry, greater than 1/3, right? Because 1 over 5 definitely less than 3, right? So greater than the 1/3 means the two region of the x should be either x less than 1/4, -1/4, or less than x greater than the 1/3. Uh, this one is suppose a, b, c, d, e, f are constant for all values of x. So we have two quadratics are equal for all values. All values, okay? Once you see the all values means any x, you need to pick special x. Any special x, okay? Easy for you. Now let's convert in this. This one becomes a minus d of the x squared plus the b minus e of the x plus the c minus f equals to 0, right? So pick a x, okay? Any x. Set x equal to 0. What do we have? So c minus f equal to 0 means c equals f, right? Okay. C equals F means this is gone, right? So we have the A minus D of the X, right? Plus B minus E times the X equals to 0, right? So now let's see. Set X equals to 1. We have the A minus D plus the B minus E equals to 0. Set X to -1. We have the A minus D plus the b minus e equals to 0. Solving this one, right? We take a minus d as a variable and the b minus e as the second variable, right? We see the b minus e equals 0, a minus d equals 0, so we can solve as b equals e and a equals d. And together with c equals f, then we can combine to prove it. Next is we have a triangle has both a perimeter and the area of 30, okay? So we have a right triangle. Let's see, it is the ABC. We have the A and the B, right? The perimeter is the A plus B plus the root A square plus the B square equals 30. Okay, then the area is 30 is half of the A times B is equal to 30. This one gives the equivalent to AB equals 60. Okay, so we see the A plus B and AB, right? A strong hint is A plus B as a variable, then A plus B bracket square minus 2AB is equal to 30, right? So now let's take the AB as a variable. It's t plus the t square minus the 120 is equal to 30. Then we have the t square minus 120 is equal to 30 minus t of the square. Then we square on both sides, right? So t should be less than 30, otherwise it doesn't work, okay? Remember this, and the t square minus 120 is equal to the 900 minus the 60t plus the t square. So we have the t square are gone, right? So then we have the 60t is equal to the 1020. So we have the t equals to the 102 over 6 is equal to 1 over 40, 17, right? Okay, now we know the a plus b is equal to 17. And the a times b is equal to 60. Okay, now the AB are roots of a quadratic of the m square minus 17m plus the 60 equals 0. So we can factorize as m minus the 15, m minus 12, and the m minus 5 equals to 0. So we have the a b is equal to 12 and 5. No matter which one, all that doesn't matter, right? So if you know the two legs are 12 and 5, so you know the c is equal to 13. So that's why the answer is 5, 12, 13. So question number 35. We want to find all of the pairs of the AB such that these are equal, right? So all of the radius for all the x, right? For any x is x square, ax square equal to x square. For any of the x, a must equal to 1, right? So now we can compare is the x square minus 2ax plus the a square, then 4x square minus 4bx plus the b square, right? This is on the left side is equal to, on the right side is x square minus 6x plus 9 and 4x square, right? So we see the x square coefficients is 5 and 5, right? So we know the 2a plus 4b is equal to 6. The a square plus b square is equal to 9. Okay, now we can solve this one, right? The first one, from the first one, we know the a equals 3 minus the 2b. Then we substitute here to get a quadratic, okay? So 3 minus 2b of the square plus the b square is equal to 9. Now we can have the 5b square minus 12 of the b plus 9, right, equals to 0. So we know the b either equals to 0 or b equals to the 12 over 5. Okay, so if b equals to 0, right, then A equals to 3. If B equals to, substitute here, right? B equals to 5 over 12 is 5 over 24. So negative 9 over 5. Okay. So question number 36. So we know the x squared of the y is equal to 24. Y fourth to the z over x is to the 30. We want to solve this, right? Okay, so this one is, let's see, okay? We want to solve the y and the y to the 5 and z to the 5, right? So now let's see what's going on here, okay? So the first, let's time them together, okay? So x squared times the y to the 5, right? And over the x, okay? So we get the y to the 5 first, right? Is equal to 24 times the 30. So we know the y to the 5 is 24 times the 30 over x. Okay, now we get the y to the 5, right? Now let's see how we can get z to the 5. Okay, so we want to cancel the y, right? So you can see if we 4 times of the first is x to the 8, y to the 4th, and the z to the 4th. Okay, then divided by y to the 4th z over x, right? Then will equal to the 24 of the 4 over 30. So this one, let's see, is equal to the x to the 9. Y is gone, right? Then we have the z to the 5 is equal to 24 to the 4 and the 30. Now we can solve the z5. Okay, so the z to the 5 equal to 30 times x to the 9 over 24 to the 4. Okay, so now let's see. Now we have the z of the 5 times y of the 5 is equal to 24 times 30 over x times the 30 of the x to the 9th and the 24 to the 4th. Then will become the x to the 8. Okay, x to the 8. We have the 30 square over 24 to the cube. Now we can solve the x to the 8 over yz of the 5 is 24 of the cube minus, over 30 square, right? So the final answer will be the 16 times 24 over 25. Okay. Next. So we have 10 people to form a circle and each pick a number and tells it to its two neighbors adjacent to him in the circle. Then each person computes and announces the average of the numbers of his two neighbors. Okay, so the number here is the average of this. The number 1 is the average of this number and this number. 2 is average of this number and this number. 3 is average of this number and this number. So the figure shown below is the average announced by each person. Okay, so the number was picked by person who had the average of 6. So now let's see. The original number is A1, A2, A3, A4, A5, A6, A7, A8, A9, and A10. Okay, so we can double this number, means the 2 times the 1 is equal to the A2 plus A10, right? We have all this kind of so on and so forth relationship. We want to solve the A6. Now, if we want to solve the A6, we'd better have an equation of the A6, right? So now let's see what kind of equation we can get on the A6, okay? So we know the the 5, right? So we know the A5, right, is 10. The reported by 5, right, is 10 equal to the A4 plus the A6. So the A4 is equal to 10 minus A6, right? And the number reported by 7, right, is 14 is equal to the A6 plus A8, right? So also the A8 is also equal to the 14 minus the A6, right? Now let's see that we can construct a second equation here, right? So the number of the A3, right? The 3 is so the 6 is equal to the A2 plus the A4, right? Is A2 plus the 10 minus A6. So now we can solve the A2 is equal to the A6 minus 4. So A2 is equal to the A6 minus 4, right? Move one step forward. Okay. Now if A6 is equal to A2 is A6 minus 4, now we can take a look at A1, right? A1, so 2 is equal to the A10, right? Plus the A6 minus 4. So now we can see the A10 is equal to 6 minus A6, right? So A10 is equal to the 6 minus A6. Okay, now finally we can see this is the parameterized by A6. This is parameterized by A6. So we know the A9, the reported number is 18 is equal to 6 minus A6 plus the 14 minus A6. So now we can set up the equation, right? Once we have the equation is 20 minus the 2 of the A6 equal to 18. So A6 is 1. So next is we want to find all the values for the satisfy this type of equation, right? So we know the ABCD, neither of them can be 0, right? Otherwise it doesn't satisfy. So now we can do the AC over AD is equal to C over D is equal to 3 over 2, right? And BC over BD also equal to C over D is 9 over 6, right? Is 3 over 2. So that means if we can parameterize C is 2t and D equal to C equals 3t, then D equals to 2t, right? Now what we can do is the AC is A times 3t equals 6. Then B times 3t equals 9. So we can say A equals the 2 over t and B equals to the 3 over t, right? So then the solution will be the 2 over t, 3 over t, then C is 3t, then D is the 2t, the A, B, C, D is equal to this with t not equal to 0. Okay, the question 39. So we want to find all the pairs of this such that this and this both satisfied. Okay, so it's a very routine way is we want to substitute become a quadratic of a single variable, right? So in this way we can do the y is equal to the 2 over 3 minus 3x. Okay, from here we can get this. Then we can substitute this one to the quadratic term. Okay, so we substitute this one to the quadratic term becomes the 9x squared plus 3 of the 2 over 3 minus 3x of the square minus 7 of the x is equal to 0. Then what we can have is the 36x squared plus 3 of the negative 4 of the x plus 4 over 3 then minus the 7x equals to 0. Okay. Then what we can do is further simplify it is the 36 of the x squared the minus 19 of the x then plus the 4 over 3 equals to 0. Then what we have is 12 and 3, then negative 1 and negative 4 over 3. Okay. Now we can have it. What we can have is 12x minus 1 and 3x minus the 4 over 3 equals 0. So we can have the x1 equals 1 over 12. So x2 equals the 4 over 9. And then the y1 equals to the 5 over 12. Okay. And the y2 is equal to negative 2 over 3. Yeah. I will record the second part on the second video. Thank you. Bye bye.